Hello, nice to see you again. I'm Chris. In this video, I'll show you what's the difference between pointer and reference. And pointer and reference are both powerful tools in TwinCAT and allow us to have a efficiency, memory management, and data manipulations. However, these two tools have a very clear big difference, and we need to understand them very deep and when to design and implementations our code. Before I continue to my tutorial, let me introduce myself again. I'm Chris. I come from Hong Kong. I'm now working some stuff with factory automations. In the left hand side, there are some informations of my video, YouTube, blog, and FA radio. So if you like it, then you can check all these informations. Okay, so why we need to use pointer or reference? Pointer and reference are stored as many bytes as it takes to hold the address on the computer. The pointer reference are therefore much smaller than what is pointed to. It is much faster and more memory efficient to use this smaller size when storing data or passing parameters to functions. So a very big advantage or a very big point that why we need to use pointer and functions and reference is because, for example, now we have a function block that we accept a input of a 2000 bytes array. So you have two ways. You can directly copy these 2000 bytes of array into passing into a function block, or use pointer to reference to just pass the address to your function block, then to use the reference function block to execute your code. So you make your function will make your code more fast and more easy memory efficiency. And let me go a little bit more deep about pointer. So pointer is a variable that hold the memory locations of other variables. Then pointer variables return the value that at the pointer stored in the pointer variable prefix with the pointer sampled. Then the operator they have two types of operators. The first one is simple, that was ADR. The ADR they use is so many times for the TwinCAT or this function block. And the pointer variables can reference to lint. And an initialized pointer can also be created, and you can initialize at any point inside your program and can re-initialize in many times that you want. And there's a very main function, so you need to use is the pointer checks. So to monitor the pointer memory access at runtime, this point is called check pointer functions can be used. It is important to note that this checkpoint has no default implementations and must innovate by the user themselves. So while you create this code, they have some scratch code inside, but you need to implement it again to fix your applications. And the pressure of the check pointer function is, well, either the function transfer the pointer points to a relative memory address or not, or even is the data type is a match of the pointer or not. And this point is to be checked, and if both condition is okay, the pointer shall be returned. If not, the function must create you must create a process for this error handling. So what kind of advantage when we use pointer? So the first one is allow us to use the lone values. The pointer can be set as a lone value, but the reference cannot reference. They allow more flexibility in situations where a variables may and may not be present, and reference can not be relocated, which is useful when dealing with a complex structure or when performing operations on multiple variables in the same time. In this time, pointer will be help you. And there's a very big point. It's called dynamic memory allocations. The pointers can be allowed to rearrange the memory dynamically, but reference cannot. It allows more dynamic and flexible use of memory in situations when even when you compile, you don't know how much of memory that you need to use. And pointer are more efficient at passing large data structure than reference. So, and then we need to think about talk about reference. So reference variables are used to reference to the variables that can assign to them. The reference variable return the address of the variables and have two types of operators. And the reference variable cannot be set to rooms, and it can only initialize when they're created, and they cannot reinitialize again in the program. And also you have a operator called is valid reference to check your reference is okay or not. So here's an example that I screenshot from the Beckhoff's homepage. Then these functions can be used to check whenever a reference point is to a value, for example, a non-zero value something. Okay, so what kind of orientation when we use reference? It's easy to use because no need to depending index of pointer, you don't need to use any special symbol or ADR. You can just use reference to. And the type safety, and in this with a pointer, when with a reference, the compiler will check the basic type is same as assigned between two reference. Okay, so I think we talked is enough. Now we can jump into demo to see 8-bit deep of pointer and reference. Let's go. Hello guys, now we open the TwinCAT. Now we can start to make some program to understand a bit deeper more about the pointer and reference. So first of all, I create some points to separate each examples. So go to points, add, and points. So in here, my first example, my name is called P pointer, P-O-I-N-T-E-R, right? So just soon it will be big. First of all, I will show you how to define the pointer in TwinCAT. So in here, you can see my I pointer is equal to pointer to int, and I have my R pointer is pointer to real, and I have a IDI pointer is pointer to dint. Great. Then I'll have some value for us to check, some variables for us to check the pointer is working or not. So with my int and underscore my int both in integer type, and I've my view and my view is also in a view type, and finally I have my dint and my dint is in the double integer type. Great. Then we can start to make our program. So I think if you remember my slides before that, you use ADR to get the address of our variables. So in here, do the same thing. My I pointer is equal to ADR of my int. Great. And now after that, we get the pointer. We use the ADR functions to get the memory address of my int variables. Then we can directly access this variable by using the pointer. How can you do this? Is my I pointer is equal to underscore my int. So now this value will write into the pointer that store the memory address of the my int. So this value, if this will change, and my int also change. I think it's very clear. So we just do the program. My R pointer is equal to ADR of my view. Then my view, my R pointer, my R point, sorry, let me delete this one. My R pointer is equal to my view. Great. Okay, then do the same thing for our W integer pointer is equal to ADR my dint. Okay, then my di pointer is equal to my dint. Great. Okay, so finally we can just call the program here, P pointer, and then to connect our system, go to system. Here's the TwinCAT run I'm running for. I'm running the small PC, and then just log in the program again. Yes, great. And play button. Okay, now you see the pointer have some strange value, but don't worry, it's just a memory address. that of my int and my will on my dint. So what we need to do is to change a value in here. For example, change v14, and here is change 1.2345667 something. And for the last ID, my dint, I change to some big value. Okay, and to change it. Great, you see, we get the result. It just only change this value, but my int and my will, my dint also change. So these are basic operations of the pointer. Then we can go to the next examples. So right click and point. Here is p pointer example 2. In this time, you define some value and to see if you define a wrong data type of the pointer. So you have A, B, C is int, okay. Then if my I pointer is equal to pointer to int, then I have my I pointer value is equal to int. Then I have one more, my pointer value 2 is equal to int2, and I have a test view value is equal to view. Great. And then first of all, we need to write our variables. So I have a equal to 1, b equal to 2, and c is equal to 3. Then after, we can point out with a normal value, pointer to a normal operations. Then my I pointer, okay, my I pointer is equal to ADR of A. Then we get the address of variable A. Then with my I pointer is equal to B. So now A, the value will be equal to B. So now the value is between 2 in here. Okay. Then finally, then we get this value. My I pointer value is equal to my I pointer with this sample. So finally, this value also equal to 2. And then just do some strange operations. My I pointer, change the pointer again, is equal to ADR of the a real value. Test real value. And then my I pointer value 2 is equal to my I pointer. So this time, this will be very strange because the data is not matched. So the value is pointing is to 2 bytes and 4 bytes. The memory address is totally different. So and data is totally different, but TwinCAT will not want us because it's the pointer. You can assign to everything that you want, if a memory address that you want. And then we can call the program b pointer example 2. Okay. Just download it. See what happens again. Great, no error. And you see 2, but here, for example, I change the value to 3415. So let's see what happened here. You see there's some very strange value because actually this value is not pointing to the right pointer. In your case, you get very strange value. Please very take care to don't point a different data types. If your case you do have a very strange value and your program be crash and some stuff. Okay, so we now the string combinations. Now we can try to make other example. This example I'll show you how to make a dynamic array. P example pointer example 3. Great, open it. And first of all, I will create a dynamic array. Array is equal to pointer to int. Great. And then my value is int. And then I'll create a counter. So how can we create a dynamic array? We can use a dynamic array is equal to new int10. Great. Now create a array with 10 elements. So what the only do is just same with the for loop operations. For I equal to 0 to 9 do dynamic arrays is equal to I is equal to I plus 1 and then multiply I. Great. And then we would like to show the value, and just wait a second. I would like to show the value. So for I equals to 0 to 9 and do my value is equal to dynamic array I. Okay, I think it will be very clear. And then finally, don't forget to delete our array. Delete dynamic array. Okay, it's done. Then we can download the program again. Go to sorry, we need to call the program again. P pointer example 3, and just download it. Great, it download, and go to here. Then okay, so finally the value is 19, and you see the value is okay. Then we delete our array to make sure that we don't hold the memory, and even that we finish our program. So I think our second program is finished. Then we can go to the next one. The next one is I would like to create a way to walk inside the array. Just create a new project, a new program called P pointer example 4. Great. And in array is equal to array 06 of int is equal to 1 2 3 4 5 6. Great. Okay, then I have my pointer start. My pointer start is equal to pointer to int is equal to ADR of my array. Just set in inside value to make sure I do not have any mistake. Then I have a other pointer to point to my array elements. Int pointer to int. Okay. I might have an error here. Okay, here. Okay. Then I have a my value is int. I have a jump bit for me. And finally, I have a counter. Counter is equal to 1. Then we can start the program. If binc, then my pointer item is equal to my pointer start plus I minus 1 equal to multiply size of int. Then we can jump to each pointer with 2 bytes, so we can point exactly what we want. And then my value is equal to my pointer item with pointer. Then I equal to I plus 1. If I is more than 7, it's very important because we need to make sure we will not go too much for our memory. And after we plus 6, 7 times, we need to go back to 1. I equal to 1. And then finally, just don't forget to reset our jump bit. Okay, then we can go to P pointer example 4. Log in to see what happened. Okay, then we can press the jump button. It will jump to 1 2 3 4 5 7 1 2 3 4 5 6, and then go back to 1. And then you see, great. Okay, and then 6 and 7, there will be 1 again. Yeah, true. Okay, now finally I'll show you a pointer check program. So go to add and pointer view impact checks and check in the pointer checks. And here is some important code. Before is just a example for you to know that what you need to how can you catch the pointer error, and actually you need to implement yourself to for the execution, for what kind of process you need to do when you have a pointer error. So we can now create a pointer fault program, and here's p pointer fault. Great. No need too much program, just I would like to point to a pointer that is never insolite. It's pointer to int, and then my value is bool and b fault test. My value is inch, sorry, inch. Great. And then if b fault test, then my value is equal to my pointer, I pointer value. Then b fault set is equal to false, and actually it will be fault because I didn't insolite my pointer. So just call this program to see what happened. P pointer fault. Download. Yes. Okay, it seems a low error in here. We can try to turn this bit, and then the runtime will be go to fault. Let's see. Boom. You see now the program is wrong in here, and then the sort of message you see that is accepting the I think it's here, accepting to the invalid address. So how can I get this text? Actually, it's here. Pointer check. This check pointer failed due to a invalid address. So you can use this program to program your own process while they have a pointer error. So what you do here, we can just go to runtime, run again to make sure no error. Okay, then finally I will show you some program, sample program, our reference, p reference. Okay, just do the same things. My I reference equal to ELENC reference to int. My R reference is equal to ref ELENC to view. It's just int. And I have my di reference is equal to ELENC to dint. Then they have the same value, so I will not need to do too much in here. P reference here, okay. And then I just do one time. My I reference is reference equal to my int. Then my I reference is equal to underscore my int. Underscore my int. So what you do in here, we will reference my I reference here, we reference to my int, and then even if I change my I reference, then it will also change my int because they are reference to the same address. So go to main, call it p reference. Download. Great. And then press start button. Great. And I'll go here. I will change this one to 1, 2, 3, 4. Then same 1, 2, 3, 4. It changed. Very easy. And then finally, I'll show you more the other reference arrangement and to see actually how SimDB debug how reference work. and a new program, B reference 2, and same thing, A, B, and C, and this int, and my reference is equal to LEFERENCE to INT, and I'll have a my reference value int. So what I do here is very easy. Just insert the value. Maybe insert in here. Okay, so A is equal to 1, B is equal to 2, and C is equal to 3. So my reference is equal to reference equal to A. So now my reference will be reference to A, and then my reference equal to B. So now my reference will change to value B, it means 2, and then finally A will change to 2 also, and finally my reference value is equal to my reference. Okay, so it means now finally my reference value will be also 2. Let's go to main, and then BREF 2, and then log in, play it. See, is what we do. So I think we have a 20 minutes of live code. I think you know what is a reference and what is a pointer and how to operate. And I hope you like my videos. And if you have any problems, please comment and email to me. Then I'll try my best to answer you. So today's tutorial is enough. I hope you have a good day. So see you next time. Bye bye.